Ladies and gentlemen, a warm welcome to the Festo booth located in Esslingen near Stuttgart. Hello, we are streaming live to wherever you are in the world right now here at ACHEMA Pulse. We're happy to be there, and we are happy that you are there in our next session, which is about a very, very important topic. My name is Dorothy Gelmar, and I'd like to introduce our speaker, our experts. It's Dr. Eckhard Roos. Hello, Eckhard.
Hello, Doro.
A very important topic that we will talk about in the next 30 minutes, right?
Yes, of course.
What did you prepare?
Just look at the discussion we have before the election here in Germany. You can see that this is an important topic. How to come to a climate-neutral living let's say, to save our planet. Yes, very important topic.
And we all have to take part. We all have to take action.
Of course.
We can't say the other one should do this. We all have to start at ourselves.
Yes.
So we have 30 minutes. Are you prepared for questions from the audience?
Yes, of course.
Ladies and gentlemen, it's also your turn. If there is something coming in your mind and you say, I would discuss that with Dr. Eckhard Roos live here, send me your question via the chat function. It will appear here, and at the end, so in 20-25 minutes, I will join you again and pose your question to Dr. Eckhard Roos. So
okay,
let's go.
Thank you for the kind introduction, Doro, and I would also like to welcome you to my presentation about climate-neutral production and what kind of benefits can digitalization as well as automation give on the road to these kind of production. But before I start, let's just have a look where we are. And you see here statistics. You don't have to go into the details. The statistics about the climate neutral, let's say, savings achieved from 1990 to 2020. This is a chart for Germany and an official chart from the Bundesumweltamt. And the good news is that we achieved last year our targets. The bad news is that 9% of the reduction just comes from the year 2020. This means this is not really a sustainable reduction of CO2. And this leads to a change in the target setting. I think you are very well aware that the European Union already reduced, or let's say strengthened the target for reduction to 2030 from -40% to -55%. And also the German government gave this target also to the society to come down from I have to look, -55 in this case to -65%. Now you can say, okay, this is number crunching, but what is behind this? This means that from last year, 2020, to 2030, we have to reduce in the related sectors the CO2 emissions by 40%. So it's a huge amount for the industry, but also for the energy production, but also for buildings and so on and so on. And if you look on the industry sector was not so strong in reducing the CO2 emissions from 1990 to this year or to last year, especially from 2010 to 2019. As you can see it here on the screen, there was nearly no reduction in the CO2 emissions. So we have to improve the situation because also the industry has to contribute to this. And the good news is that a lot of companies, and I show here on the left side of the slide a few examples, like Bayer, like Dow, like others, like Merck, for example, they already defined a year when they want to have a climate-neutral production within the period to 2050. I will use Bayer. Bayer announced, for example, in 2030 is the year they want to have a climate-neutral production. The other companies mentioned here, they have already target settings for at least a certain reduction in percentage in a certain predefined period. So we are on a good way looking at the industries. But what is now behind the climate neutral production? If you can see here the classification of the life cycle assessment for a product. Let's focus in the beginning, in the middle of this slide. This is called Scope 1, and Scope 1 represent the CO2 emissions of a company like Festo, for example. We have company cars with emissions. Also, we use energy in our productions, so there might be also a certain portion for the energy consumption related to a CO2 footprint. On the left side, you can see the so-called upstream activities. This means these are the production processes where we get our, let's say, pre-products in our factory. This means when these parts arrive, they already have a certain CO2 footprint. And then on the right side, you see the life cycle of the product. And the life cycle of the product is representing the energy consumption when the product is used in production. For example, pneumatic actuators, they consume compressed air, and then of course this might be also related to a CO2 footprint. So this represents the whole life cycle. And what we did is we had a pre-investigation and I used this quarter turn actuator, which you see on the slide, as an example. Coming back to the left side means we have profiles, shafts and so on, which we import into our factory. We do the assembly and later on we shift it to the customers and users, operators for production. So when these parts arrive, they have already a global footprint of 20 kilograms CO2 equivalent. We add 2.15 kilograms on it, means in our own production facilities, we just add 10% to the overall already existing CO2 footprint of this product. Then we shift it to the operators for usage. And if you now have a look, what does it mean for a life cycle footprint? You see here two calculations. We assumed, for example, a safety factor, which is very important for the next step. A safety factor of 1/3 means 33%, because actuators are usually oversized. They have to do the work, they have to operate, also under, let's say, unforeseen conditions. We also assumed an operation mode of 24 hours, and the two charts represent a different kind of operation. The one chart on the top represents a 2-time switching per hour, and the other chart on the bottom right side represents 20 switching cycles per hour. And what you here clearly can see, there is a significant difference in the CO2 footprint, depending, of course, on the case of operation. And I will use the example of the upper side. When you only have 2 switching cycles per hour, then the CO2 footprint for the production still is a significant portion of the overall CO2 footprint if you look at the cumulated CO2 footprint for a life cycle of 10 years. But what can then automation contribute to reduce this? And I would like to show one example. And for this representation of the example, I will use this device. Everybody knows this device. This is a mobile phone. You know Festo for a long period of time as supplier of pneumatics for decades. And also pneumatics is a very proven technology also for decades in automation of process plants. Now you can ask yourself, what the hell has pneumatics to do with digitalization? Very simple. We bring two worlds together, means mechanics as well as software. And we use the principle of the mobile phone. The principle of the mobile phone is that you have one hardware platform standardized, and the real functionality, and everybody is using different functionalities on the mobile phone, is implemented by installing apps. So what we think is that by implementing this principle, we solved the usual contradiction between standardization as well as flexibility on the other side. Standardization, always you have benefits and have no flexibility in engineering and operation, and vice versa. If you have flexibility, then you usually have no standards and cannot achieve the benefits out of that. So we solved this usual contradiction, and I would like to give you one example which makes it very clear. You see here the principle, on the left side the mobile phone, on the right side automation, and on this type of component shown on the right side, you can implement all the functionalities you can see also on the right side with the traditional pneumatic automation. Means you can buy, I make it black and white, 1,000 of the pieces beginning of the year. You don't have to know what you will do afterwards with them because the real functionality is achieved by installing these apps. And of course, looking at the maintenance, look at the spare parts on stock. You can imagine what kind of benefit you get. You have only one spare part in hardware on stock instead of all the other spare parts you can see on this slide. So this is already a clear benefit for this component. But what has this now to do with CO2? And I would like to encourage you in general to look how many apps are available. I would like to encourage you to discuss with us what are your problems, because our experience is also that in our discussions with customers we get new ideas for new apps. But coming back to CO2 emission, I would like to use one video, and in this video you can see a linear actuator. He has to do some movement going back even with no load, and whenever he reaches the end position the chamber is filled up to 6 bar when the supply pressure is 6 bar. Using the app in the example, the upper side, you can clearly see that reaching the end position, the chamber is not filled to 6 bar. So you save already a certain portion of pressure, compressed air, and you can still use, and this is a very important topic, the safety factor if required. So you have the advantage of having the safety factor available, but on the other side, save the compressed air when you use a safety factor, and everybody is using a safety factor in the engineering. A second app you can install in addition to this Eco app is an app testing leakages. You see here a device, for example, in a wood handling system. Doing operations means pressurizing the wood to the bottom. And after a predefined number of circles, you can define a leakage test. And what is the advantage now? The advantage of this leakage test is that if you have a leakage, you get the information directly where the leakage is. So nobody has to run around, look where the leakage might be. So you save man hours for detecting the leakages, and also you can immediately start with fixing the leakages. So also big advantages when it comes to leakage detection. And of course, this is CO2 relevant. I would like to come back to my example with the DFP D40. I use the example on the left side, and I would like to compare now the footprint for the 20 cycle operation per hour. You can see here again on the slide, on the x-axis, the operation time in years, and you see year 0 is the footprint just the product has from the production. Cumulated, we end up with 461 kilogram after 10 years. And if you now use the motion terminal, this is then the second chart now on the bottom, and then you end up with 216 kilogram. So you save, just by using the motion app, to more than 50% of the CO2 footprint. And again, the Eco app, in addition with the leakage detection is an additional benefit. Now we talk about CO2, but a lot of companies, of course, have to look for the ROI and has to look for profitability. And what is behind now, looking at the profitability using these kind of equipment. What we also did is we calculated one rotary packer in this case, a cement bag filling unit, rotating and have 12 filling stations. Each filling station is equipped with 3 pneumatic actuators. And we compared, in this case, traditional automation means linear actuators, single solenoid valves, compared to the motion terminal, the intelligent digitized component. And we calculated in this case a safety factor from 30 to 40%. Don't worry, you don't have to go to this slide to all the wording. Just please focus, because I would like to explain it on the chart on the left bottom. You can see here a comparison of the investment costs and the life cycle costs for these two variants. Traditional automation on the left side in the chart, and the digitized motion terminal on the right side. And what you can clearly see is one thing: the investment costs are the blue part of the chart, of the bar, and the green one are the consumed compressed air during a period of 20 years in this case. Of course, the motion terminal is more expensive in the investment. In this case, you can see clearly, looking at the blue part of the bars, 20% more in investment. But during the life cycle, you have a lot of savings, and at the end, you have 1/3 of the net present value saved looking at a period of 20 years. Okay, now, few people say, this is a long period, but we calculated it also, and I mentioned it here on the slide. 5 years, after 5 years already, you have in the net present value a saving of 10%. So it's not always a question of the operation period of the plant. Still, you have the big savings. And I would like to emphasize one thing. This calculation was done with a, let's say, neutral tool from the ZVEI, the Association of the German Electric and Electronic Industry. We developed this to compare alternatives with respect to life cycle costs. I would like to encourage you also to have a look on this web page, because you can download this tool free of charge. Now, I explained possibilities on the shop floor, on the field level. Now I would like to step up the automation pyramid, go to the cloud level. Of course, field data are then consolidated and then are transmitted to the cloud. And I would like to use one example, and you can see the example here on the in this model plant here, an air preparation unit. Intelligent air preparation unit with the connectivity to the cloud, also shown here. And what is special, or what can you achieve? Customers, operators in Germany use this intelligent air preparation unit in connectivity with the cloud application to monitor the consumption of compressed air. This not only for one production line on their side, but for 3 production lines. So they can also then benchmark one production line to the other, and can get, let's say, a best of class production line on the site. They also would like to extend this, of course, on a global base, because you can easily then also benchmark air consumption in the production line in Brazil, with India, with Germany. Why I emphasize this case? Because these kind of application, just taking the old air preparation unit out and bringing an intelligent one in and analyzing data in the cloud, gives you a very easy way to learn and get first steps of experience in digitalization if you do not have these kind of expertise up to now. Because there is no risk for the production. No risk for the production, but you can easily take these kind of applications to get the first steps and experiences. The second example I would like to show is artificial intelligence. And here I would like to focus on machine learning tools. Machine learning tools you can install on edge or in the cloud. You remember the air preparation unit and analysis of different consumptions in Brazil, India, as well as Germany. This, of course, makes sense to install these kind of analysis tools in the cloud. But if you want to analyze a production step, then it makes sense to have this installation done on edge. I explained yesterday how you can do it using another example. I will not go into this example today due to time reasons, but I would like to show another example out of the automotive industry. But this is not related only to the automotive industry. You can transfer these easily also to the bulk handling, because we have similar or the same discussions, I have to say, also with bulk handling customers. You see here a production unit, a welding process. Two parts come together in one location, are fixed by 9 pneumatic actuators. Then the welding process is done, and then the welded part is taken away. Next two parts come, are fixed, and so on. This is done on a frequency of 1.5 minutes. So a very fast process in the automotive industry, and you can imagine if you have a failure, if you have to repair one of these actuators, you have loss of productivity immediately. Someone has to go, someone has to exchange the actuator, and so on. So what we did is we installed on Edge also these kind of machine learning tools, and we simulated failures which occur in these kind of applications. Means leakages, means friction, as well as changes in the supply pressure. And what you can see here is two things. First of all, machine learning tools drain themselves. There is no programming effort, drain themselves to analyze and to monitor the process. And then they get a set of healthy data representing the process. Then, of course, they can easily detect abnormal behavior because then there is a change in the process. And then looking at the errors, you can see here, they can not only detect anomalies in the process, but also get first indications what might have happened in the process. We monitored in this case the time period between the electrical energization of the solenoid valve and the actuator leaving the end position and the actuator reaching the other end position. These are two sets of data, and also vice versa. And you can clearly see the change of the arrow already indicates what the problem might be. So machine learning tools give you not only the advantage that they detect abnormal behavior, but also to show what could be the reason for that. So we clearly say these kind of tools will improve the production tremendously, because they can avoid shutdowns, unplanned shutdowns, and we can shift maintenance in planned maintenance shutdowns. So we are pretty sure that we can detect, for example, these kind of failures increasing friction 7, 10, 14 days before we really might have a problem. And this is, from our point of view, a strong basis also for the implementation of predictive maintenance concepts. The last topic I would like to show is Festo Energy Services. Of course, we can consult your installation with pneumatics, give you recommendations how to improve, but also in the design phase, in the engineering phase, we can give you recommendations and hints how to improve it. I will only show a short video of roughly 1 minute, and then you can see what, especially also for brownfield, but also for greenfield plants, we can deliver. Okay, I think here you get an impression what we can deliver for brownfield as well as for greenfield plants, also to reduce the CO2 significantly by digitalization and automation concepts. Okay.
Dr. Eckhard Roos, thank you very much for sharing your insights, your knowledge with us. Ladies and gentlemen, thank you for your attention, and thank you also for telling us that the quality of the videos is not very good. We don't know why that is. We are streaming and recording here in high quality, and we don't know why you don't receive that in that way, but we will tell this the ACHEMA Pulse team. Maybe we can share. And there is one thing, or many of you, ladies and gentlemen, asked us if it's possible to send your presentation to them. We shared the link of Dr. Eckhard Roos' profile here in the chat function. Click on that and you can contact Eckhard Roos for more information and maybe for the presentation or more.
Good.
Eckhard, there is one question that we received from Simon. Simon, thank you very much for that great input. He says, good morning, Eckhard. First of all, you mentioned that the industry was not so successful in the reduction of CO2 emissions in the past. What were the reasons for that?
The main reason, from my point of view, is that the industry is always looking for, let's say, short periods on the return on invest. And we have in saving energy the problem that the huge energy saving potential has normally also large return on invest periods. So the energy saving investments always are in competition with other investments in marketing, in logistics. This is one thing. Means then the companies usually go for the investments with smaller ROI periods. This is one thing. The other thing is you must consider that, of course, if you have long payback periods, then also you have to consider, is the business model of my business still valid in 6 years? Will I still produce, for example, in this location in 6 years? So does it really make sense to improve the infrastructure? These are additional topics, but I think we had in the past also clever, let's say, supporting activities. I will mention one supporting activity from the Swiss government.
Yeah.
Swiss government just supported investments with a payback period longer than 5 years. Longer than 5 years, just to get the thing on the road.
Wow.
And to avoid this hurdle, let's say, of always competing against other investments with a shorter payback period.
Okay, a good way other countries also maybe should think about. There is one more question.
This is interesting because we actually, in Germany, we have a discussion now, especially for the before the elections, about this topic. And we discuss exactly in ZWEI, for example, the Association of the Industry and so on, what we can improve to get this done. And this exactly and others topics are part of this discussion.
We have to get in action.
Yes,
something has to happen. What are the obstacles for the CO2 reduction, and how can we overcome these obstacles?
Yeah, this is mainly what I mentioned already. Yes, we have to give, let's say, better chances to that. For example, total cost of ownership. There is a huge discussion. What period has to be considered when we talk about total cost of ownership? Do we have to consider 5 years of operation, or do we have to consider, for example, the technical lifetime of a product? So just depending on this different criteria, we have totally different evaluations of the return on investment.
Dr. Eckhard Roos, thank you so much for sharing this knowledge with us. Ladies and gentlemen, thanks for your attention, and sorry for the bad quality of the slides. One in the chat said the video quality was good, but the slides were not. We're sorry for that, but contact us, check out our company profile, or just click on the link where we shared Dr. Eckhard Roos' profile to get more information via video call, chat, a call, or anything. We also would like to invite you to the next session that will happen today today here at ACHEMA Pulse from our Festo booth to you, where you are at the office or home office, ladies and gentlemen. The next session is at 10:45, and it's about functional safety at Festo. Also a very important topic for sure. All our experts are prepared to answer your questions, also in your language. So we have our colleagues from the different countries to share their knowledge and insights with you. Eckhard Roos, thanks again for the insights.
Thank you.
Thanks for being here. And ladies and gentlemen, we hope to see you in the next session. Stay tuned and get in contact with us. Let's interact. Bye-bye from Esslingen.